Okay, we're gonna look at finding the greatest common factor from a list of integers, and since we're talking about polynomials, but we're gonna base this off there a little bit. If we look at multiplying a couple polynomials, let's say x plus 2 and x plus 3. Well, we know we're getting x squared, 2x and 3x's plus 5x plus 6. Okay? So basically we're saying this polynomial, x squared plus 5x plus 6, x plus 2 and x plus 3 are the factors of that polynomial. Okay. Basically what we're doing is factoring as the reverse process of multiplication. So anyways, the first thing we should do is see whether terms of polynomials have a common factor. If we have one, we can write the polynomial as a product by factoring out the common factor. Okay? We usually do this through factoring out the greatest common factor. Okay. Now, what this means is the greatest common factor. That's a list of a list of integers, because that's what we're looking at here from a list of numbers. The greatest common factor from a list of integers that we have is the largest integer as a factor of all integers in the list. Okay. So if we thought, okay, let's say we have a list of 12 and 20. Okay. The greatest common factor of 12 and 20 is 4, because 4 is the largest integer that is a factor of both 12 and 20. Okay? And when we have large numbers or large integers, it can be difficult to find this. So really what we want to do, and I guess I'll list this in numbered order, is we want to write each number as a product of primes. So basically we want to factor each number down and doing prime factorization. Okay. Then we want to identify common factors. Right, and then 3. And the last thing we want to do is all the common factors we have, the product of those. The product of, say 2, because that's step 2, is the greatest common factor. Okay. If we don't have one, then the greatest common factor is 1. So what does this mean? Well, let's look at this from a couple different examples. First, let's say we have a couple numbers. Let's say we have 28 and 40. And we want to find the greatest common factor between 28 and 40. Well, if we were to write this as a product of primes, we would see 28 is equal to 2 times 2 times 7. 40 is equal to 2 times 2 times 2 times 5. So basically what we're saying here is identify what's common. Well, what's common between the two? Well, we have a 2 common there. We have a 2 common here, and that's it. So if we take the factors that are common in each and multiply them, 2 times 2 is equal to 4. The greatest common factor between 28 and 40 is 4. Now, well, if we look at 3 numbers, maybe. Let's say we have 15, 18, and 66. Okay. So if we want to break 15 down, we know that's 5 times 3. 18 is, let's see, 3 times 3 times 2. 66 is going to be a little different. That's going to be what? 11 times 3 times 2. So if we think about this, what do we have in common? Well, nope, not 5. 3. Everybody has a 3. Only 2 of them have a 2, not all of them. All of them have to have it. So the greatest common factor of 15, 18, and 66 is 3. Okay. So if we're looking at a list of integers, this is how we look and find the greatest common factor. We can factor the numbers using a factored tree. If we looked at 28, of course, we have 4 and 7. We break that 4 down into 2 and 2. We could use a factor tree if we'd like. But the problem, the main thing is to be able to factor numbers and then identify the common factors and multiply them together to get what the greatest common factor is. So I hope this helps with greatest common factors from a list of integers. Next, we're going to be doing it from a list of terms as it relates specifically to polynomials. So hope you have a good one.